Hold on. So just really quick, I want to go through the last images you sent me to make sure you understand how we got the answers. So give me a sec. As much as I always think I'm prepared for these, I'm not. So all right, so we go. Just this here. Solve the trigonometric equation for all values of 0 to 2 pi. So here's the main thing that I missed about this was the domain, I'd say, of the answers, or actually that could be the range. So the uh no domain. So what are the values from 0 to 2 pi that actually work? So there are many values that work for this. So first I went and tried to solve this equation by subtracting out 3 and then divide by 4. So we're looking for sine squared. Oop, different mouse. It's weird. Anything equals 3/4. So I can take the square root of that and say this is going to be square root of 3/2. Now the first thing that comes to mind is what angle is, this should be next there. What angle gives us a sine of 3√3/2? And that is going to be 60 degrees, which is pi/3. So that is one of the answers. But it's asking what is going to give us it throughout all of this. So I kind of think there's two answers at first, but let's see what happens. So here is our unit circle, and we have pi/3, which is 60 degrees, which is here. But also we have a reference angle over here too, and here. These are all supposed to be straight lines. As I said before, I'm not good with drawing with the mouse, but especially with this using a different computer now. So we have this pi/3. That's one of the answers. And in the positive region, we also have this 2, which should be 2 pi/3. And I would say that should be it, but it's not. There's more. There is this one and this one. Now, why we want to include these ones is because in the original equation, the sine of this angle is being squared. So if you were to take the sine of, say, this one, this is 4 pi/3. I'd be wondering, what is 3 pi/3? And what 3 pi/3 is just 180. That's not included in the solution. So we also have 5 pi/3. If you take the sine of these angles, let's see what happens. So if I were to take sine of 4 pi/3, I would expect it to be negative because of this stuff. This all students take calculus or whatever messed up kind of acronym you want to kind of derive from that. So this is going to be negative √3/2. But thing is in the equation, they do say it's squared, so all those wind up being positive. So all those actually do work. So you do want to include those two last angles, 4 pi/3 and 5 pi/3. Just to show you briefly what that means is that if you were to say, take the original equation and say 4 sine squared and stick 4 pi/3 in there, let's see what will happen. And so 4, just 4. Then we have sine of this guy and that's squared. So note that the notation here, you have the squared on the outside, it means the same thing as this, which I think you know. We're going to see if that's equal to 0. So let's take sine of 4 pi over 3. Well, that's over here. So that is a negative zone of sine, but a reference angle of pi over 3. So that's going to be a negative angle. Sorry, negative result of negative root 3 over 2. The thing is that becomes positive, so it becomes like it looks like everything else in the end. So that becomes oh, yeah, place to put this. So 4 times it's a root 3 over 2. That's gonna be regular 3 over 4. There's no negatives because negative square is positive, and subtracting 3. And so what does this come out to be? So 4 over 4 is 1. So doing 3 minus 3, that is 0. So that works out. So your final answer has all these things in them. So it was asking for what makes sense in all these regions, and what I was missing was the fact that it that's what I was missing. So I was just considering like the first two regions or whatever made sense in the inverse sense. So let me move on from here. And you get to look at some data as I'm switching back and forth between things. So you said it was wrong. This was all these things. This is another way to look at it. Um, and right here, they're talking about angles past the negative x-axis or before the positive x-axis. So in other words, like reference angles in which it makes sense. So if you're given 0 to 2 pi, just consider everything that is like that angle in that region. So what I mean by like is like, so you had pi over 3 as being the answer, basically, but also everything has a reference angle of pi over 3. So you could take a second look at that diagram and see like why that makes sense. Here we have this data again. All right, so let's take a look at the next question, and that is asking this in the same region. So sine squared minus 1 equals 0. So let's first solve the equation and see what that gets us. Because when you solve it, you get an equation with some results. My handwriting is horrible with this thing. So then you get sine, and you're going to take the square root of 1. Square root of 1 is just 1. And so you want to see when that's true in this region. So let's take a look at what happens there. So I'm going to draw the unit circle. Now I have ones or zeros. What you want to consider are these 4 places that make the unit circle. This guy, and this. And I'm going to try to make a circle based on that. Not perfect, but you get the idea. So here I'm going to fill in the coordinates. This is 0, 1, 1, 0, and so forth. All x's and y's. Now, why do this? Is because we want to find out what the sine is. Now, the sine is always the y coordinate. if you get mixed up with this, always remember alphabetically. So cosine is x, sine is y. So sine being 1 will be the y coordinate of 1. That only happens in one place over here. Now, if that's in radians, that's pi over 2. That's pi over 2 because this is 0. This is half of pi. And here we have pi. We got 3 pi over 2. So it seems like we should only put one answer, and that is the angle pi over 2. But the thing is, just looking at the equation is not enough. You don't just want to solve this, you want to look at the original equation itself. You want to see if anything else works that's similar. So what is similar to 1? Well, that'll be -1. So how to get a -1 will be figure this angle, 3 pi over 2. So maybe that is a possibility. So let's see if it's going to work. So if I put 3 pi over 2, here's what it looks like. So we have sine over here, sine squared of 3 pi over 2. Minus 1 equals 0. Let's see if that, with the parentheses in the wrong place there. Let's see if this makes sense. So I'm going to put a question mark over here. So remember that sine and with the squared. I keep reiterating this point, but it's really important. So whenever you have the squared there, that actually means the square is on the outside. So you find out this thing first, and then you have bigger parentheses around this, and you find the square there. So sine of 3 pi over 2 is -1. It's -1 because you see it over here in the unit circle. But then you actually are squaring that and subtracting 1. So when you square -1, you get 1. -1 is 0. So both of these work. So this is a lot to think about. But the important things, like when you get a question like this for all these, just note that probably there's going to be more than one thing that works. And sometimes there's two, sometimes there's even four. Sometimes there's nothing. So let's look at the next thing. And so say hi to Zendaya. And let's look forward to this guy. Solve this for all these values. So right away, we look at this equation. There might be one solution, there might be two, there might be 0, there might be like 4. So let's be on alert for all those things and find out what is happening. So I'm using a lot of Panther because I am clicking around for drawing tools like this. Right, so let's first try to solve it. So we have cosine squared, and we're going to move over the 1. Cosine squared is 1. So I'm going to take the square root of that and say 1 is cosine 1. All right, so 1 is a special value, and that relates to the unit circle. So I'm going to make a picture of that. And we want to ask when is cosine 1. So we want to say that cosine is the x values of the unit circle. So let me draw a little circle around this and find out when the x values are 1. So right here I see it. This should be like 1, 0. And that's the only thing I see, but maybe I should mark this too. This is -1, 0. And the reason I'm marking that is because cosine is squared in the original equation. So maybe both of those work. Um, these other ones, not so much. So we have 0, 1. You could see if you plug in 0 into the original equation, it's well, excuse me for a second. I was actually not saying the right thing, so I caught myself there. Um, if you plug in a 0 into here, it actually does produce a 1. So these are the values we actually want to be looking for, is this 0 and this 0. So let's see how that works. So we have this cosine of 0 squared minus 1. So cosine of 0 is just 1. Then we subtract 1, we get 0. So that works. So this point works. And this point works as well. So we want to say both of those. And we want it to be within this range. Sorry, domain. So the words domain and range are a little bit confusing because, like, when somebody says range in real life, they mean like the range of two different things. But domain specifically in math means x values. So you do want to say that these are x values here. So what works? We have 0. I believe that's the only one that works. Okay, for coordinates. Taking a step back, taking a pause because I realized like some of these things I'm jumping the gun on. So when you take the cosine of 0, we're talking about 0 degrees. That is this right here. That's also 0 radians. That produces this here, the 1 that makes it work. And if we say cosine of whatever the angle this is, we get -1, and we square that. That also works. So the points that actually work are this and this. So that is two angles. That is this angle and this angle. So we have the angle 0. And we also got pi. Pi comes from this. All right, so let's see how that works out. So we have cosine squared of pi minus 1. So cosine of pi is 0. Sorry, not 0. Keep saying the wrong thing. Cosine of pi is -1. And we square that, we get 1. Minus 1 equals 0. So we get these two values. I have to stop saying the wrong stuff. So just take a good look at that and make sure you understand that. If you got any questions, I'm probably going to make this video private because I'm making too many mistakes and it's pretty embarrassing. So there we go. And then we got this last guy here. All right, solve this trig equation for all these values here. All right, so the first thing, again, I'm gonna try to solve the equation. And this step is important because it gets you a general idea of what's happening. But also you gotta remember all the other things that might be happening in it. All right, so we've got um, this guy for cosine squared x equals 1. And now I'm going to divide by 4. And take the square root. So I'm looking for the cosine of x equals 1/2. Now, if cosine is 1/2, that means 60 degrees in the first quadrant. And that could mean other things in other quadrant. So I'm going to draw kind of 60 degrees here. But I'm also going to draw other 60 degrees elsewhere and see which ones make sense. Now, some of these are positive and some of them are negative. All right, so we have this, we have Alex, sucks, cock. Right, so we have right here, we got the positive region right there. That's pi over 3. And we got this guy that is negative in that region. So maybe we'll hold off on that for a second. Now this one we get 5 pi over 3. So based on science, it seems like those should be it. But we do have these other we do have this squared. So maybe we want to see what happens in these other regions. So we have this is what is this? This is 2 pi over 3. So we find cosine of 2 pi over 3. That's going to be negative, but it's going to relate to the reference angle, which is this here. So that is going to be yeah, 1/2, but also negative. But then when we square that, we're going to get a positive. I multiply by 4, subtract 1. So like in the end, actually all these things do matter. So we're going to have 2 pi over 3 and 4 pi over 3. So hopefully I got all this right. Again, it was a little confusing with the signs, but the main thing that when we went over this, what I missed was the fact that it has to be in between these two regions. And there you go. Let's say goodbye to Zendaya. Say goodbye.